welcome back to my channel. Suhail this side. So this would be the third video in the LLD series, and in this video we will design elevator system, right, based on real life what we actually see, right? For example, in shopping malls, in buildings, in offices, in tower apartments, right? So based on realistic manner we will try to design this elevator system. We will talk about different challenges while designing this system. For example, how the load balancing between the elevators would happen, right? Again, we will discuss different algorithms, right, to reduce the people waiting time to get into the elevator so that they can quickly reach out to the destination floor. So we will discuss all sort of challenges, all sort of problems while designing this system. So again, just like the earlier videos, earlier LLD videos, so we will code this system as well, everything together, right? Just watch the video till the end. There will be a lot to learn and this video would be fun to watch, right? So without wasting time, let's get started. Let's discuss the requirements at a very high level to design this complete system. Okay, so what we need to design? We need to design the control system which will control the multiple elevators in a building, right? The system should handle multiple user requests from any floor and assign the appropriate elevator so that the person who has pressed the button can reach out to the destination floor, right? So what are the basic requirements? The basic requirement is our system should handle multiple requests at the same time. So whenever in any LLD problem or any kind of problem, whenever you are given a statement like this, that you have to support multiple requests at the same time, it simply means you have to use multi-threading by any means, right? Without multi-threading it can't be achieved, right? So in this video also we would use multi-threading concepts a lot. So the guys who has basic understanding of multi-threading, right, they are good to follow the video. But the guys who doesn't know any basic multi-threading knowledge, or who doesn't know any multi-threading concepts, they just need to watch my multi-threading series, video number 1 to video number 4. There I have covered lot of all the basic multi-threading concepts. For example, the wait notify mechanism, synchronization mechanism, volatile synchronized keywords, and locking mechanism, how the threads are managed by the operating system. I have covered a lot, right? So all those basic knowledge would come handy, and you would be you would relate the video, or you would easily understand all the code which I would be writing in front of you. Okay, now the second requirement could be we need to support the load balancing between the elevators, right? And the third requirement is all the displays should display the correct status as and when elevator is moving or stopped, right? Again, but we need to design this complete system with lot of design patterns along with multi-threading, right? And we need to design in such a way so that if we want to plug and play some of the features, we should be able to do that. For example, if we want to change the scheduling algorithm later on, we should be able to do that, right? And at the end of this video I will publish the follow-ups which you guys has to try. For example, lighting up all the floor buttons when user presses up or down button, right? And also how to handle starvation request. I'll come up on the follow-up questions later on, but this is for you guys to try all these follow-up questions, and I will publish this follow-up question answer solution in the next video, right? So let's discuss how what are the entities involved in this complete system, right? So to simplify everything, I have just done the pictorial representation of a building, right, floor wise. For example, there is a building, right? And in a building what happen is, uh, just let me, yeah, this is a building, right? And in a building what happens is, you have different floors, right? Floor number 1, floor number 2, floor number 3, and on each floor you have multiple elevators. For example, in this picture you can see the 3 elevators are there, right? Elevator 1, elevator 2, elevator 3. 3 elevators are there, but every elevator has its own buttons, for example up and down button, up and down button, and on every elevator you can see on which floor this particular elevator has reached. Let's call this as floor display, right? And just for simplicity I have drawn this. Let's consider this is the inside part of elevator. For example, when you go into the elevator you can see the panel there where the person can press the floor button where he want to go actually. For example, 1 to 8 floors I have, just for simplicity I have shown up here. And here also there is a display which keeps showing the number where the floor on which floor the lift is currently placed, right, where the lift has currently reached, right? So let's call this as elevator inside panel, right? And the display, let's call this as elevator inside display panel, right? And on the floor, right, we have two buttons, three buttons. I got three buttons actually. This is the floor panel. Let's consider of up and down, two buttons in a floor panel. And this is a floor display. It's a very high level what we see everywhere in shopping mall, in buildings, everywhere we see this kind of uh, uh, mechanism, right? Now we will design this complete problem in two phases, right? In first phase, what we will do, we will create this complete design with different classes and relationship between them, right? For example, there could be an elevator class, right? There could be a floor panel, there could be a floor display, there could be inside panel. So we will create different classes and we will establish relationship between all the classes, right? The second phase, we would do the realistic implementation with all the code and all the different cases. Let's assume for here also I have drawn the picture. For example, this is a floor, there are two elevators and a person who is on floor 2, right? And it's pressing the up or down button, right? Let's assume he's pressing the up button, and elevator from floor 0 has come up to the floor 2, and person can go into the elevator, and based on his decision, once he enters into the elevator he can choose where to go actually. Similarly, for example, this elevator 2, right, it is coming down from floor 5 to floor 0, right? And meanwhile the person who is on floor 4, right, can choose where to go. For example, he has pressed the down button to reach out to floor number, let's assume 1, right? So this elevator can pick up this person, and once the person gets into the elevator he can press the appropriate button and reach to the destination floor, right? Again, we will design, or we will discuss each and every case, how the display would automatically uh, shown, right? Which number should be shown automatically. We would use complete event pattern to update the displays appropriately, to update the floor panels appropriately. For example, user presses the this, for example, let's assume user press up button, right? There could be three persons who are standing on this floor, everyone has to go up, right? Now one, if any of the person has presses up button, all the panels, right, all the up button in the floor panel, right, would automatically turn on, right? So that user is already aware that okay, this button is already pressed, right? So anyways, one or the other elevator would definitely come on this floor, and the other persons who are already on this floor can go inside the elevator and can choose where each and everyone wants to go, right? So we would use the events very heavily in this complete system. We would completely use the event driven architecture, or you can say we would use the observer design pattern, right? We would use the different kind of design patterns actually to complete this solution, right? So as you can see, we need to firstly in phase 1 we need to come up with the classes and relationship between them. So let's start thinking in that direction, right? if you see the pictorial representation which I have drawn here, right? So you can easily identify few of the entities which you can consider in your design, right? For example, the elevator, the floor buttons are there, the display panel is there, right? And similarly the inside panel is there, right? So as a general practice, for any kind of LLD problems which you use actually day-to-day basis, for example elevators that you use day-to-day basis in offices, in shopping malls, in your building apartments, right? So for these kind of LLD problems, what you can do, you can just try to draw a visual image in your mind, or take a pen and paper and just draw all the pictures which you use daily. That's what I have also done, right? The similar way. So with that you would easily able to identify, okay, which entity would fit there, which class should have this responsibility, right? For example, the inside panel, this is a responsibility for elevator only, right? That it has to be inside the elevator, right? So just draw an image, you would easily identify few of the entities and relationship between them. So let's quickly identify it, and what I'll do is I'll just open my IntelliJ, and there I'll start writing the classes, and we will also maintain the relationships between them. Okay, so what we can do here is I can just, okay, so this is the same multi-threading code repository which I have already shared on GitHub and also in the links, right? So in this same repository, what I'll do is I'll just create the elevator, right? Elevator system design. So what I'll do is here I'll just create the new package, that is elevator design elevator, right? So elevator system package I have created, right? Now what I need to do, let's quickly identify the entities, right? So what all the entities are there? First of all, we have an elevator. Okay, let's create an elevator then, right? Let's create an elevator class. Okay, now what should be the data inside the elevator? What should be the member variables? What functions this elevator should expose? Let's think in that direction. Okay, so every elevator, it should have some ID. Okay, right? Then every elevator should depict, okay, at which floor it is currently reached, right? So it means it should have the current floor, right? And also elevator has to move up, down, and there is one more case. For example, the elevator can be idle. For example, user presses button floor 4, and once he gets out of the floor 4, there is no one who is requesting the elevator, so the elevator will stay on floor 4 only, right? So we have different directions, up, down and idle, right? So what we can do here is we can consider the directions, right? So what we need to do is we need to consider the directions, different directions, right? Up, down, and let's assume the idle. These are the three different directions, but these are static. So what we can do is we can create an enum for this. Okay, so direction enum I have created. So what I'll do is there would be three values: up, down and idle, right? Now the elevator has ID, the elevator has current floor, the elevator has direction, right? Let's assume the current direction in the initially it should be idle, right? These are the three data members. And what else? Let's see the pictorial representation. Let's see the diagram. Okay, what is elevator is having? Elevator is having the inside panel as well, right? So okay, let's create the inside panel, right? Inside panel, right? Now there should be a relationship between inside panel, right, with the elevator. Why? Because the from inside panel only the request would somehow the user would press the button on inside panel and then eventually will reach the destination floor. Okay, So let's create the inside panel class, right? So what else, what the inside panel should have? Okay, so the inside panel should have the elevator, right? So let's create the constructor. This would never be changed. Let's create this as a final uh, variable. And okay, what are the functions the inside panel would expose? Okay, so the inside panel, let's say the diagram again. On inside panel, what user usually press? It would press the button to go to the specific floor. Okay, so what it should expose? It should expose, for example, public void press floor button. Let's say this is the uh, thing, right? And this, which floor it has to go? It has to be passed from outside, right? Because once the person enters into the elevator, after then only it will identify, okay, which floor to go. Okay, now the inside panel I have created, the elevator I have created, right? And what else we have? Okay, let's see again. Okay, the inside panel we have created. Now okay, we have the floor button, floor display, right? These are the two more things which we have, right, which we can easily identify from the diagram. Let's create the floor button. Okay, floor button. Okay, so what the floor button would have? Floor button is present on each floor. Okay, so it should have the floor, right? For which floor there would be different objects for each and every floor, right? Now what else it should have? Okay, the floor button, for example, on a floor there are four elevators, right? But all the four elevators would be having different floor button, right? Different button. So it should have the elevator, for which elevator this button is, right? So let's create the constructor. Okay, so let's create this as final. Let's create this also as final. Okay, now we have the floor button. Okay, what are the functionalities the floor button provides? Okay, so let's see the diagram again. The floor button, someone would press up button on the floor and someone might press down button on the floor, right? So it should expose two functionalities: public void press up button, right? And also it should expose public void press down button, right? So now these are the two functionalities which floor button is having, right? Now let's create the class for floor display as well, right? So floor display. Okay, so floor display, what it would have? Every floor it would have display, and for every elevator the display would be different, similar to floor button, right? Private in floor and private, because for every elevator this floor but display would be different, right? And it should have the elevator. Let's consider this also as final, right? And let's create the constructor. Okay, now the floor display exposes which functionality? The floor display, for example, this is the floor display, right? What it should expose? Okay, it is just simply displaying the status, okay, on which floor the elevator is currently reached, right? Let's consider this public void display. Let's consider this is the basic function or basic uh, functionality the floor displays exposing. Now what we are having is, we have identified the major entities, and we have uh, created the classes for that. We have also established the relationships. For example, the floor button is there, the elevator are there, right? Now what else we need to have? Okay, now we have the major entities. No, but who will create this elevator? Who will, how this elevator would be constructed, or how the floor button would be added into this elevator, or inside panel would be added into this elevator, right? Who will be doing all this activity, right? let's create the means everyone terms it differently. Some guys terms manager, so I like to call it controller. For example, elevator controller. Let's keep it simple. The elevator controller is there. Okay, so what it should have, it should have the list of elevators, right? The list of elevators it should have, right? So let's array list, yeah, it should have the list of elevators, right? But still, how means the elevator still has to be constructed. Okay, so what we would do is we can expose the constructor for this. Okay, just select none, right? So from outside or the client, or when the application gets up, right, what it needs to specify, what it needs to specify, okay, how many floors this building is currently having, and on each floor how many elevators are there, right? For simplicity and consistency, let's assume the elevator, 3 elevators or 4 elevators on each floor, right? The same number of elevators on each floor are present, right? So what we can do is int num elevators, right, and int number of floors, right? So these are the two things which would we would be needing to construct all the elevators and its association, right? Now before moving further, let's we see in the elevator class we have the elevator. Okay, who is responsible for creating the inside panel? Okay, so does inside panel exist if the elevator is not there? No, because it doesn't serve any purpose in that case, right? So what we'll do is I can have the constructor, right, and the elevator has should have id that should be passed via constructor. And the other thing, for example, let's assume the current floor initially is also 0, it starts from 0 floor, ground floor, and also the inside panel would also be responsible, uh, this is the responsibility for elevator to create the inside panel, right? So let's, now we have created the inside panel as well, right? Now let's come back to the elevator controller, right? Now we are given, okay, these are the, this is the configuration, these are the number of elevators, and these are the number of floors, right? Now this controller would create the elevators, right? So many elevators based on the floors, right? So what we can do is, yeah, so the elevator, it would be created by this, right? Let's assume the id is I, the for loop id, right? So the elevator has been created, right? Now the elevator has been created, but this, for example, every floor is having 3 elevators, right? So for each floor, right, for each floor it should, means the same elevator should be created on each floor, right? The elevator 0, it should be created on each floor, then elevator 1, it should be created on each floor, right? This is how we can simply create elevators on each floor. So what I can do is int floor is equal to 0, right? Floor is less than number of floors, and floor plus plus, right? So what we need to construct, okay, we need to construct on each floor, what we need to construct, we need to construct two things, floor button and floor display. Let's see the diagram again, the floor button and floor display, right? So what we can do here is floor button, right, or floor display. Let's create the first display, right, and we can create the floor display. Okay, what we need to pass, we need to pass the floor, right? Okay, what else we need to pass, we need to pass the elevator, right? Similar to this, what we can do is we have to create the floor button as well, right? Floor button, floor button, new floor button, and what we need to pass, the floor and the elevator. Simple. Okay, so this is how we can create these things. but let's keep it simple. What I can do here is, okay, let's quickly first evaluate, okay, what would be the responsibilities for controller. Okay, someone would uh, press, or someone, for example, the person on floor 0, right? Let's see the diagram again. Let's see this way. The person on floor 2 press the up button to go upwards, right? So what would happen? So it would he would press the up button on floor 0, on floor 2 actually, right? So after then only the lift comes up from floor 0 to 2, right? So it has to specify two things. What are what are those two things? It has to specify, okay, where to go, that is the direction. And the other thing, it has to what is other thing, it knows the floor, right? So floor and the direction where the person wants to go, we know these two things, right? So this request, we can segregate this kind of request as a outside request. But when the person gets inside the elevator, right, what else is there? The in what Once the person gets into the elevator, there is only an inside panel, right? So on that inside panel only, the person can press the appropriate floor button where he wants to go, right? So we can separate these two requests. How we can separate is the outside request and the inside request. Okay, so what we know on the outside request? Outside request pressed on a floor panel, right? What are the information available? We know the floor, we know the direction. Elevator is still not known, right? Because it has to be served dynamically. We don't know which elevator would come up, right? If there are multiple elevators. And for inside request, what we know? We know, okay, where the person wants to go, that is the where person wants to go. For example, the person wants to go to the floor 10, so we know, okay, that this floor the person would want to go. What else we know? We already know the elevator where the person has already entered. For example, person presses the inside panel of floor inside the elevator 0 or elevator 1 or elevator 2. So the elevator is already known to us, right? And based on that, the person would go to the destination floor. In For inside kind of request, there is no need for load balancing, right? Load balancing means the elevator should dynamically serve. For example, if there are multiple elevators, right? So which elevator actually would serve the user request? That is, you can call that as a load balancing, right? But once the person gets inside the elevator, that there is no load balancing, because the same elevator would serve the request, right? So we can segregate these two things so that the our design should be maintainable and scalable, right? So what we can do is, we can create the request, right? So two types of request we have. What we can do is, I can create the simple enum again to make the design simple. Let's call this as request type. Okay, so request type, and what I can do is outside and inside. These are the two request types we already know. Okay, what else I want to have? I have to create the elevator request, right? For example, the outside request, or you can name it as elevator request, outside request. We'll change it later if required, but let's keep it in consistence with the elevator. I have just created the elevator request. Okay, now what we know in this case? We know the floor, right? And uh, we know the floor and we know the direction, what the user would have to pass, right? And we also need to know the request type, right? So that we can, if later on we want to add on enhancements based on outside request, inside request, load balancing is not supported, we can modify or we can extend the design in an easily, right? Otherwise, if we don't maintain it, then it would be difficult to manage later on, right? So what I can do here is, here also I can just private final, private final, and private final, right? I can just create the constructor, and what I can do here is I can just have this, and the request type, what I can do is I can just create the request type as outside. Let's expose the getters for elevator request. Now we have the elevator request. The elevator request is there, right? And now we know, okay, that all the basic entities are done actually, right? Now let's come back again to this elevator controller. Okay, let's say user on floor 2 would, what all options he have if he wants to go to any destination floor. He has two options: either he can press up or he can press down, right? So let's assume public void press up button, right? Press up button at floor, right? Because this is a controller system, right, which is managing all the elevators, right? So from outside what it would come, okay, that on which floor this button has been pressed, right? And for which elevator this button is pressed, that also is very important, right? For example, there are multiple elevators, there are 3 elevators, and person comes and he press the floor button up for elevator 0. So we should know, okay, that for this elevator the button has pressed, right? So let's assume this elevator ID, right? And similar to this, what else, similar to this, we have the press down button, right? So what we can do is press down button, right? These are the two things, right? Floor and elevator ID in this case, we, yeah, elevator ID also we know. Okay, now, okay, because since this is the central system which will manage all the requests, right, inside outside, so this is, it is also the responsibility for this class only to handle the inside request. For example, public void press inside button, let's assume this is the method which we can expose, right? And what we know actually in this case, press inside button, what we know the floor, right? We know the floor, okay, on which floor, or not floor, we know the elevator ID, right? For which elevator this button has been pressed, right? So we know, okay, we got all the functionalities, basic functionalities. What I can do is similar to this elevators I have holding, what I can do here is I can just, for simplicity, so that our search operation would be easily manageable, we can easily identify all the floor buttons and everything. What I'll do is I can just have the floor, and here I'll just have the floor button, right? Floor buttons, I'll just create the data structure so that I can have all the floor buttons in memory for a easy purpose, right? So floor display is there. What I can do here is the floor buttons, right, compute if absent for a particular floor, right? Because there could be multiple floor buttons, right? If on that floor no button has been added, I can create the new array list, and I can add new and new floor button. By this way we would be having all the floor buttons in memory as well, right? So we have the floor buttons, we have the elevator, right? But initial discussion, what I have told you, okay, that the multiple request has to be served at the same time, right? So that means the multi-threading we have to use by any means, right? Now, okay, let's see the pictorial representation. Okay, what you think, okay, what do you think, okay, that which should be the thread, what would be the responsibility for thread, okay? So if you see the diagram, the elevator should run continuously, right? The elevator should run continuously and should process the request as and when it comes to the elevator, right? This is the core functionality for the elevator. So what we can do is we can create the elevator as a thread, right? Public elevator implements, sorry, implements runnable, right? So I have created this elevator as a thread, and what I'll do is I'll just implement the run method. Okay, now I have the elevator, I have the elevator as a thread actually. Now to keep this thread running, as we have seen in the multi-threading videos, we need to do something like this while running or while true, whatever you have, right? So with this, the thread would keep running continuously, right? So private volatile boolean running is equal to true. Let's assume the initial value for this running flag is true. Now one thing, the if the thread keeps on running continuously, right, how the elevator would process the request, right? How the elevator would process the request. Okay, now in this, whenever we are using threads and that thread has to run continuously, that means we need to use somehow queues to store the data, and so that the thread can look into that queue or any kind of data structure which is holding that particular objects, and later on can process it, right? So it means we somehow need to have buffer where, right, where we will store each and every request, right? Each and every request, right? So how we can store this, right? How we can store this? Now this is another challenge. Okay, now which data structure we need to have, right? That is a very important decision, which data structure we must have. Okay, let's see the diagram again. Let's see the pictorial representation. Let's see the use case, right? Now let's assume the elevator is currently on floor 0, right? And let's consider the different cases, up and down cases both, right? Let's consider, for simplicity, I have depicted this image with the floor 5 and similar for down case. For example, at t0, timestamp 0, right, the person 2, right, presses up button on floor 3, right? The timestamp 0 presses up button on floor 3. If we use the list data structure, okay, how the data would be stored? Firstly, the 3 would be stored, and later on, let's assume at t1, the person 1 presses up button, right? Now how the data would be stored? Because at t0 the third floor has come, the third floor would be stored. At t1 the floor 1 request has come, the 1 would be stored. This is how it would store the data, right? Okay, now if the data is stored in this manner, let's assume the lift is going upwards. Do you think the lift should go to the floor 3 and then would come to the floor 1, because the lift is already going upwards and at T2 only the elevator getting started, right? So what data structure we should have? Because the floor 1 would also be served if the request would have been like this, 1 and 3, because both has to go up. For example, both has to go up to floor 5, right? Their destination is floor 5. Now if we could have stored the data in this way, both the requests should have been served in a single go, right? So ordering is important. That is what we evaluated till now, right, for up case. Now similar to that, let's say the down case. The lift is already on floor 5, right, and on T0 the person P3, let's assume person P3 presses down button, right? The floor 1 would be added, right, as per the request. The firstly floor 1 request would come, and at timestamp 1 the other person presses the button 3, he also has to go down, right? So this is how the request would come, but the elevator is getting started on T2 at T2 timestamp. So if we have to serve this request in one go, it means here also the ordering matters. If the ordering would have been, for example, 3 comma 1, right? So both the requests should have been served, right, in one go, right? The elevator is already going downwards, so the floor 3 person would go inside the elevator, and then eventually the floor 1 person would go inside the elevator. So somehow we need an ordering. Okay, now we need to think, okay, which data structure is giving us this functionality. Okay, the ordering we need. Okay, so it simply means we need ordering, and we also need to get the elements one by one, right? We have to get the elements or get the request one by one, right? So which is the correct data structure for this? It simply means queue. And which kind of queue? If we have to maintain the order, what we need to have in this queue? This queue has to be designed specifically for this ordering. It should have been priority queue, right? So we evaluated, okay, this is the data structure we need to have. Okay, now the other thing is, do you think we need to contain, or we need to have two queues, or one queue would solve the purpose? Okay, so if we keep the queue as one, then again we need to maintain different cases. So I'm not saying it is not possible, it is possible, but you need to have your logic very complex logic. To keep the design simple, it's better if we have the up queue different and down queue different. It would be handled very easily, right? So let's consider this way. Let's consider we have the two queues, public priority queue, and here also we have the integer. The up queue is there, right, and the down queue is there, right? So we evaluated the data structure. Okay, that this is the data structure which we would be having. But for down queue the ordering would be reverse, right? And for up queue the ordering would be in ascending order, right? Now to process these up queue and down queue requests, someone has to add into this queue, right? Whose responsibility is that? For example, let's say controller submits the request, okay, that this is the floor where person wants to go. So the elevator should know, okay, which all requests it has to serve, right? Let's call this, so it has to expose the functionality, for example, add request, right? And add request, it also has to have pass the floor, for which floor the request is this, right? If floor is less than current floor, right? If floor is less than current floor, means current floor is already, let's see this way, right? If floor, let's say 5, right, and current floor is, for example, current floor, for example, 2. So floor is greater than current floor, right? So in this case, what we need to, where we need to go? We need to go upwards, right? Floor is greater than current floor, right? Where we need to go? We need to go upwards, right? So in which queue it should be added? It should be added in the up queue. Up queue dot add, right? And add, what we need to add? The floor. Simple. And similarly, if the floor is less than current floor, we have to we have to add into the down queue, right? So it is simple. If the lift is already on the current floor, right? So we can simply print out the message that the elevator is already, or elevator, or I can just, for better, elevator ID, right, is already at floor, and I can pass the floor. right? It is as simple as that. No, okay. So but since this is a thread which continuously being running, so this request for adding and removing from the queue, right, it should be synchronous. So let's call this as synchronized method. So the guys who are not aware of the synchronized functionality, just watch the multi-threading series. You would be easily getting to know, okay, what all things are there, right? So now this is done. The up queue and down queue we have added into the queues, right? Now we also need to set the direction as well. For example, you press the button and then the lift, let's assume the idle, right? But it starts showing the direction first, right? So what we can do here is, if, right, if the direction is idle, because this is the only case which we need to handle, because if the lift is idle, then it has to show the current direction. Okay, so direction is equal to, right, direction is equal to, if floor is greater than current floor, right, then it should show the direction up, otherwise direction down. That's it, right? So now we have added into this request, we have added the request into this elevator, right? Now, okay, who will add the particular request, who will add this request into the elevator, right? That is controller. The controller would add the request, right? There is no one who would add the request, right? Now how the controller would add the request, let's call this as public void submit request. Okay, and let's call this as elevator request. Let's say this request is coming from, for example, the floor button or floor display, of not from floor display, what from the floor button we have already having the press up button and press down button. So here we need to pass the elevator, because the it is a responsibility for central system to call this functionality, right, to call this to manage everything. So what I can do is private controller, I just can have this, and what I can do here is this dot controller, right? So what I can do here is, now the elevator controller I'm already having, right? So what I need to do, it has to submit the request. Now the person on any floor, okay, press the button up. Somehow let's assume it has, he has presses the up button, for example. Now let's implement this functionality, how this it would look like. The floors or the elevators, right, he has pressed the, first of all, the floor button, up button, right? So floor buttons, right, and dot get which floor it has been pressed, that we already know, and for which elevator it has pressed, that we already know, right, from the elevator id, right? And it can press the up button, and similar to this he can press the down button, right? Now we have implemented these two functionality as well, right? The floor buttons we are already having, and from the floor button we are getting the respective floor buttons, since we have constructed the floor button in such a way that the elevator id and everything is there, right? So we can easily pass the elevator id and get the correspondingly floor button and implement the functionality, right? Now let's go there, press up button. Okay, now what are there? So on which floor it is, we already know. The elevator request has to be created, right? The elevator request, and for which floor it is. For example, the floor button is for any kind of floor, any floor, and it also has to specify the direction. Since we already have the different buttons up and down, we can easily specify the direction, that is up, and we can just and here we can just say press up button at submit request, and now the floor button is pressed, and the eventually it would go onto the controller, and similar to this the down button functionality would also be implemented, right? Down button, and yeah, so now this is done, right? Now let's assume the submit request comes onto the controller, right? So how it would handle, okay? So it has to assign this particular request to an elevator, right? To which elevator we don't know. So it has to assign this request to an elevator which we don't know, which which we will see with proper different algorithms, scheduling algorithm we would see. But as of now, let's assume the elevators dot get 0, right? So it has find the elevator, right? It has find the elevator. For example, this is the best elevator as per uh, the load, as per the everything. This is the best chosen elevator which has to serve the request. So what it would do, it would just best elevator, and it would just add the request, and here what I can do is request dot floor. Now the elevator, the request has been added. How the request has been added? Corresponding based on the floor and the current floor, the elevator would decide, okay, to which queue this request would go. That is done, right? Now let's come back to the earlier functionality, right? Now for example, let's see the elevator class, right? Now this thread is continuously, first of all this thread has to be started, okay, otherwise I'll forget to start the thread as well. So let's see the elevator controller, and let's add this elevators dot add, and let's add the elevator into this elevator list, right? And then what I need to do is I need to create the thread as well. So elevator thread, let's call this as elevator thread, and here I need to pass the elevator, and I need to just start the thread. Now everything is done, right? Now we just need to implement the elevator functionality, right? The thread is there, already there. Now what is the responsibility for thread, for this thread? What is the responsibility, what it would do? Okay, it would continuously poll, okay, is there any request or not, is there any request or not? If the request is there, it would serve. Okay, so let's assume it would has to get the somehow the next floor where it wants to go. For example, get next floor, right? This is the method. For example, I can just expose this as well, get next floor, right? Now what it would do, okay, so it would return the next floor where it should go, right? And how this would know, okay, which would be the floor which I would go next? Okay, so it is very simple. What I can do here is return switch. I can, based on the direction, what my direction is, right? Because I have already set the direction as well. So based on the direction, what I can do is I can just mention, okay, that if this is the case up, then I just need to poll from up queue, right? Simple. And if it's a case down, then I need to poll from the down queue, right? And if it's idle, then just return null. We are done, right? Now we know the next floor, okay, that this is the next floor where we want, there where the person wants to go, where the elevator has to go actually, right? Now if the next floor is not null, if the next floor is not null, what we need to do? We need to, the elevator has to move to the respective floor. So in this case, the elevator has to move to the floor. right? So let's call this as move to floor, right? And what I can do is, since we are adding and polling, right, it should be in a synchronized manner, right? It should be synchronized, otherwise there could be an inconsistency in this queue, right? There could be stale data in this queue, right? So what I need to do, I need to move to the respective floor. Which floor? The next floor. Simple, right? So what I can do here is private void move to floor, right? And here what I can do is int floor, right? I got to know, okay, that this floor has to move to the respective floor. Okay, now what should be my logic? What should be my logic, right? How I can know, okay, that this is the floor I have reached. Okay, now I have the current floor. I have the current floor, right? So what I can do here is, while current floor is not equal to floor, simple, right? I need to move floor by floor, right? So current floor plus equal to 1 or minus 1, right? Because if it is going upwards, it has to be plus 1. If it is going downward, it has to be minus 1. So based on which thing I can know? The direction, simple. The direction I have already having. The direction, if it is up, it should be plus 1. If it is not up, it should be minus 1, right? Now what I can do here is, I can just log the statement as well, the elevator, right? The elevator uh, I can do, so that we would be seeing the some logs, right? Reached at floor, right? And what I can do is at current floor, right? Now it is continuously moving upwards, right? Now what I can do here is, once it reaches the floor, right, what it would do, it would open the doors, right? Let's assume I'm just writing the console statements here, opening doors, right? Now this is done. Now what else we need to handle? Once it has reached that particular floor or particular yeah, once it has reached the particular floor, right? Now there are two options, right? Either the person can go inside the floor. For example, there are two options. The person one wants to go from floor 0 to floor 4, right? And he has gone to the floor 4, but there is no one on floor 4 or any on the down floor which would trigger the elevator to go down. The elevator would would keep there only for some time, right? So there could be three directions which we have already discussed, right? Once it has reached the particular destination, right? So what we can do here is, it simply means we need to either reverse the elevator. For example, if, right, if this queue is empty, right, if, for example, if the queue is empty, we have to decide whether the elevator should reverse or should stay, right? We need to decide, right? And how we can do that? Here also we need to use synchronized, right? Synchronized, inside the this only we can change the direction, and we can change the up queue and down queue, anything, right? So what we can do here is, we can do, if up queue dot is empty, right? If my up queue is empty and my down queue is empty, there is no one who has requested further, right? So it simply means the direction for this elevator is, as of now, it's idle, right? Similarly, if my up queue, right, is not empty, or up queue is empty, right, and direction earlier was upwards, right, and down queue is not empty, right, up queue is empty, down queue not empty, and the earlier the elevator was moving upwards, now it has to reverse, right, it has to reverse, that means the direction has to be down, right. Similarly, then again the same condition, right, but it should be some bit of reverse, right, the direction down, and the down queue is empty but up queue is not empty, right. So in this case the direction would be up, right. Now we have changed the direction, we have decided, okay, now this is the time the elevator would reverse or should stay. So more or less, I guess we have completed this particular floor, and now let's see the complete flow. Okay, let's see the complete flow. The elevator controller is there. Let's call this as, let's create the one more class actually for system class, so that the client class actually, the elevator system, let's call this as elevator system, right. And here what I will do is, right, and what I can do is elevator controller, because this controller has to be created, and new elevator controller. Here what I need to pass, let's assume the number of elevators and the number of floors, let's assume this is 10, right, and eventually we need to simulate the request, right. So simulating the request, simulate requests, right, controller, someone on floor, for example someone on floor 2, right, presses the up button for elevator 0. Simple. Let's see simplicity, how simple your design is. Now once you have the core functionalities, everything is exposed, you can see how simple interface is for client. Similarly, if the controller, right, once the person gets inside the once the person gets inside the elevator, right, so here what I can do here is I can just expose the getters, right, the getter, for example I can just expose the getter, get inside panel, and get inside panel, right, and here I can pass the elevator ID, right, and what I can do here is return elevators dot get the elevator ID, and get, or here also I need to expose the getters, let's call this the getter, let's call this as the, let's call the getters direction, yeah, these are the four getters I need actually, right. So what I need to do is I need to get the inside panel, right. Now once I get the inside panel, let's say the simulation for how, let's assume this is the person who is pressing the button, controller dot get inside panel, all right. What it would do is inside panel elevator to 0, and it would press the floor button, right, it would press the floor button, for example um, floor button, he has to go, he also has to go upwards, for example 5. Or what I can do for simplicity, because this is not looking good, so get inside panel, here I'll do is I'll just pass the floor and the elevator ID here also as well, right. So what I can do is I can do this way, the elevators, once it is there, the inside panel I got it, right, and on this inside panel I would press the floor button and it would be the respective floor. Let's call this way, it would be simpler for client as well. because this getter method should not be exposed, right? Press inside button for elevator 0. Which floor it has to go? The upwards. Let's say this way. The okay. Now the person 1 on floor 2 presses up button. Now where he wants to go, that is specific to the inside button. Once he gets into the elevator, he presses okay, that on floor 5 I want to go, right? And this is how it would go there, right? You can see the simplicity, you can see how simple it is, right? Now floor button is there, everyone has its own responsibility, right? Elevator class is there, right? Everything is there. And the elevator controller we have created, which will control all the elevators, right? Similarly, request the inside panel. Here let's implement this functionality. The elevator, we already have the elevator, and what it would do, it would do elevator dot add request floor. Now our basic skeleton is everything done. Let's run this program. Let's run this program quickly and see if it works or not, right? And what I do is I'll just add some sleep, right? So that thread dot sleep, for example, this, and here I'll just add this. I can just, so that I can show you, okay, that this is how the things are working, right? And what I can do here is I can I can move this complete inside the try catch block, right? And here what I can do is thread dot current thread dot interrupt. And what I can do here is, once if there is no floor, next floor, the thread should not continuously run. We can introduce some sleep. Let's assume the 200 ms. I guess now we are good to go. The synchronize is there. The synchronized is there, where we are, wherever we are modifying the changing the direction up q down q, right? We have to make sure that it has to be in synchronized manner, so that the consistency or race condition should not be there, right? So I guess everything is done. Now let's run the program and see if it works or not, right? Let's see this. Let's see if it works or not. So okay, it is working. The elevator 0 reached at floor 1, then the elevator 0 reached at floor 2. If you see the person, if you see the call, right, the controller dot press up button at floor 0, at floor 2. So the elevator 0 starts triggering, starts going upwards to the floor 2, and once it has reached the floor 2, it has opening the doors, and once the person gets inside the elevator, he presses the inside button. Where he wants to go, he wants to go to floor 5. So the floor 5 would be there, and again here elevator has opened the doors, and the person gets out of the elevator stay idle there only, right? So this was the basic skeleton which we have designed, right? Now in the phase 2, what I would be showing you, we would be discussing the different algorithms and the load balancing, which is very important part for this particular design. So we would discuss all the challenges and all the different algorithms, how quickly the person can go to the destination floor, right, without waiting, without long waiting time. So we will see all those cases, right? So